Okay, so our 2020 robot did not have an adjustable hood. We decided not to do it to avoid some complexity, and we were pretty confident we could make the 2-point ball from a wide enough a range of positions to not need the hood, which I still believe that is true. The problem was the range capped out on the top end because of ball consistency issues where we couldn't shoot from back behind the control panel or anywhere near our driver station side of the field like we assumed we would have with some of the balls that we had. We were getting more consistent shots with our own balls than we would have with the destroyed balls, that pretty much everybody else found out too. Your shot percentages couldn't quite get high enough to make that deep two super valuable. Which means if you're having to go forward and your cycles are already taking longer, increasing your 3 percentage becomes far more valuable. And one of the ways to do that is to have an adjustable hood so you can set your shot angle to give you a much more direct shot into the 3-point goal, because once you're having to try to arc down into the 3-point shot, it doesn't work very well. It gets a lot harder to hit that shot compared to coming up and rising and having the ball rise into it. Or at least that's the current hypothesis. We would need to actually build it and test it to make sure that that is completely true. There are some potential disadvantages if you can't actually build the hood to be consistent enough to actually allow you to get repeated shots to actually go exactly where you want them, right? Once you add in that layer of adjustment, you also add potential issues with things flexing or changing their position slightly ball to ball. And all of those things could potentially be a problem. So those are things we want to design out of the system as much as we can, right? We want as stiff of a system that lets us, every time the ball goes through it, everything is in the same general location to itself, so that the balls end up at the same point at the other end, ideally, right? That's combined with like wheel velocity and some other things to make sure that's happening. Okay, so that out of the way. Okay, actually do maybe. Okay, so I went through and kind of looked at some of the design slides we had from the beginning of the season when we kind of looked at this. We didn't investigate it too much, but we looked at it a little bit. And then I also added in a bunch of stuff from 3-ish robots from this season who already either competed or had reveal videos and kind of showed what they did for their hood. One from 2012. This is 118's 2012 robot. If you want to look at the whole robot, there's an Onshape link. I don't think we need to go through it because it doesn't quite do a lot of what we want. So as part of how it does its adjustment is it has this window motor right here, this kind of gray thing. There's a gear on the end, and it has a small sector gear right here that it's just, as this drives, it's adjusting the entire angle at the back end. But since you're controlling it from the front and the ball is loading it at the back, the forces trying to move the hood back here get amplified by a lot here. So it's easier to just to like move back and forth based on how the ball interacts with it than something that's controlled at the back. And we can see kind of what that looks like in a second where the hood starts getting controlled back there. So there are options to control it up front. This saves some space. You don't have to have anything behind the hood. But we probably don't care about that most likely. Like, there's maybe some reasons why we would, like if we were using this current form factor of a robot, we were trying to add a hood, we may need to adjust it at the front because we have we have very little room behind the hood right now because it runs into our climber. But we can also just not do that in a future iteration of the robot. Here's another 2012 one. This is a little linkage. So instead of having a sector gear at all, any sort of gear rack or anything, they just drive this gear here that moves the linkage up and down through this slot, and this whole hood's able to slide back and forward to get the shot that they want. It's relatively simple. There's some sheet metal side plates, right? You have some flanges that help add some rigidity to it. They did all sheet metal pieces going between this, except for here where they have the rod, which you probably wouldn't want to do again, right? There's not too much. These sheet metal pieces don't actually add that much rigidity, right? Because we discussed sheet metal, since there's no flanges on the sides here, these whole things can just kind of bend. Is Zoom still working?
Yes.
Okay.
Yep. Still
I think you are frozen, but we can still hear you.
Can you see the screen at all?
Yeah.
Okay. You
Still on linkage hood 33.
Yeah. Okay.
Yeah.
All right. I don't know. Zoom's key. All right. I'm gonna have to do something. Zoom's being weird. It's trying to crash constantly, but still do things. Okay. So this is another one we saw at the beginning of the year. This is 2056's 2016 hood. So this is definitely a little bit of a different hood concept. I think some teams have to do this too this year, where they bring the entire hood down to some like flat level to try to go under, in 2016 to go under the low bar, and this season to go under the DJ booth, whatever, trench. So they needed more position. So like one of the positions isn't actually a fire position. When this is fully down, they would never actually fire the ball that way because the ball would basically just go straight up, which is not really what they wanted. So they have this position here, which is stopped by these pneumatic cylinders. And then when they pull that away, there's a slightly further forward one that gives them an even deeper angle shot. But this is only if they only needed one or two positions. This works fine. This probably isn't enough if we're trying to increase our three-point percentage, because we basically want a specific angle based on the distance we are away from the goal basically every time. All right, so this is another one that we had from the beginning of the season. So this is basically the gear rack hood. So you have a sector gear of some kind. You can kind of see it over on this 971 picture. And we'll look at their CAD actually in a second. And so they're able to move this up and down along a rack. Like there's bearings that are able to slide back and forth, and you get a nice consistent angle change wherever you are. That being said, you are required with this setup to like be using the motor power to kind of hold you in position. So as the ball comes through, the ball's going to try to move the rack, and the motor has to like react against that to stop the rack from moving at all or like jostling or anything like that. So this is the CAD for 971 shooter from 2017. I think I have the Onshape pulled up for that. Yeah, so we can actually look at it. So, zooms backwards. Okay, there we go. So they have a bag motor here that goes to a pulley reduction quickly. And then they have two gear stage reductions. So this is spinning. So you do a lot of reduction to get this spinning very slowly, right? So it has a lot of torque. So that offsets some of the problem with the gear rack being able to move, just because to move it, you have to, you're going through a lot of reduction on the motor. So it gets harder to actually spin this by hand, or for the ball to spin it when it's trying to go through it. All of these are stacked plates. All of these are stacked rack gear plates, so you have a lot of gear teeth across the whole thing, which also helps. So you can get there's like less play when you have wider gear faces, and it also just makes it simple enough to build them all the same for everywhere that the ball's touching. And this worked well enough for them. I think they actually put foam on this at some point on the real version. I'm not entirely sure how they swept down the bottom here and covered everything. I don't know if they used Lexan or what they did there. We'd have to look at some pictures from the real version to exactly figure out what they did. Because that's one of the points that gets really tricky, is how you transition from this empty part where the gear rack kind of like moved away, and the hood moved away, to the hooded part, and how you kind of keep that transition consistent. We'll see how a few different teams did it in a second. But that's definitely one of the big things we have to consider, is what does that look like? How is the ball supported when there isn't hood there? Or like, how do those two things overlap? That type of situation. Does that make sense what this is doing?
Yes.
This is an encoder, so they have an idea of where the hood is, because that's one of the issues we have, is right, how do we make sure we know the position of the hood? Do we have some way, either an encoder and we have some way to like home it? Is there a potentiometer or something? There are teams, I know 118 has used like a string pot to get a distance away. You could also use the encoder inside the motor if you have like a Neo 550 running it, where the encoder is already built in. We'll also look at a couple servo designs, where the servo kind of does your positioning for you as well, here in a second. Okay. What are other, nope, wrong presentation. Okay. So this is actually kind of tricky to see what they did. I had not even actually noticed what they did until I prepped for this. So their whole rack system, to be really stable, that's one of the things, is like, how do you actually move? How does this whole mechanism actually slide on everything, right? It's kind of like it's sort of like an arced elevator, right? It's having to like move in this linear fashion, but along an arc. So the way that they did it was they have these bearings here for this top shaft. So there's two bearings, both the things I've clicked in orange. And there's two rails. So there's a rail here that's off to one side, and there's a rail here that's off to the other, right? So this side is capturing it towards the shooter wheel, and this side is capturing it behind the shooter wheel, or like to the back of it. So this whole thing can slide up and down, right? That makes sense? How these bearings are sliding in this rack?
Oh, okay. Yeah, I think that when you had like first set it, I think that maybe it was a little bit slower, like the actual zoom.
Oh, sorry. Okay, I will come back in.
No, it's okay.
Yeah, I'll have it stationary while I do it. So yeah,
Okay, yeah, okay.
bearing here and here. And then there's a rail here and a rail here. Yeah, these two rails are what it's like riding on.
Okay. Yeah, that makes sense.
Yeah,
and then
so
it can go like all the way down.
Yeah, so it's able to go, these two bearings are able to go all the way down. So this is actually, for the 2017, because of how the shooter was done, this is the farthest forward it could go. The rack, like, it actually drives it back down really far, if it needed to. I doubt it shot. I'm pretty sure it shot somewhere in the middle here. I don't think it shot quite that deep. But the arcs had to be so high in 2017 because they were shooting into the boiler, which was like this horizontal goal. So the balls had to be falling in from a really high release angle. So that part is relatively easy to make sense. And actually that seems really nice to support and does everything. The inner one, however, is a little trickier to see and understand what's happening. It took me a second to even understand what was going on. So let me make sure I can give time for Onshape to open up. So you can see that there's a slot here, kind of where I've highlighted in orange. Mm-hmm. There's a slot in that plate, which is even tricky to see because it doesn't go all the way through. So there's a slot on this side, but when you rotate over, there isn't one on this side. So it's like machined into it, but it doesn't go all the way through. So it doesn't separate or anything. So there's no way to capture a rod going through it or anything, right? Mm-hmm. So what they do, and I have to use Onshape's kind of weird transparency thing. So they make transparent. There's this little bearing right there with a pin through it. So there's they press a dowel pin into this sheet, and there's a little bearing riding on it. And that's what's riding in that slot. So there's one on both sides.
Oh.
Rotated the wrong way. So
Okay.
yeah, so you can imagine this same bearing is over on this side, and it's riding in this slot. And since there's nothing, and since the slot doesn't go all the way through, they don't need any way to capture that bearing, because the bearing can't go anywhere, because it can't go into the wall and it can't go into the other side. So there's no bolt or anything. It's just a dowel pin holding that on and doing that part of the slide. And then these are countersink, so they don't hit anything because they bolt through into some sort of, like, I'm pretty sure this like standoff tube. Yeah, so this is a standoff tube. These bolt through and stack up into that to allow this whole assembly to be built. And this gap is here. Anyone have any ideas why they need that gap there? Or one of the things that makes it easier, at least. So if you don't have that gap, it becomes very, very hard, probably impossible, to take it apart, because you can't hold this tube to unscrew both of the bolts. So you could do it where you have to like unscrew one of them first while holding the other one tight, and then like take all of these plates off enough to be able to grab this. But with this here, you can grab it in the middle and back both of them out if you need to quicker. So if you like put pliers on this, you could easily take out bolts from both sides. And then there are also bearings riding on this outer back wall as well. So these are flat, and there are bearings here as well. I've selected too many things. So yeah, these two dark gray things are bearings, so that as the ball is pushing on it, it can't be flexed backwards very much. So it runs into these bearings and stops any flex going backwards. And the whole thing is relatively rigid, right? This is a pretty thick piece of material here, all relatively solid. You're not going to flex those too easily once they're all bolted together and things too. In several places, there's what, 1, 2, 3, 4, 5 bolts going through there. That's one. Oh, I'm spinning around too fast. Okay. Yeah. 1, 2, 3, 4, 5. So there's quite a few going all the way through that to make that assembly work. And there's another one that it actually, as it comes down lower, the whole rail hits more bearings. So it hits these when it's at the very top, but as it comes down and gets lower to where it's shooting more often, there's another set here and another set here. So if the ball's pushing against it, it can't, it can't flex backwards at all because it has all that support on the back end.
And did you say they ended up putting foam on the
I believe so. We can go find out. 2017 971 photo. That's weird. Why are there car pictures? 2017. There probably has the shooter. Intake. Crazy turret thing, which we don't need. So yeah, there's what it looks like in real life, but they don't have any film on it or anything. So yeah, so really nicely machined. This is almost certainly all done on their in-house router. Oh, they ended up putting a lot fewer of the actual gear racks in the real thing, it looks like. All right, so the CAD had
a different picture.
Yeah, I don't think we can see what you're
we're still in
looking
the on shape.
That's weird.
And the on shape is moving.
That's terrifying. Okay, well,
is it really behind, or is it like?
I'm guessing it's really behind. All right, so we're going to pause and redo Zoom again because
feeling that the weather's gonna change, so I'm turning off my brain for a minute. I had a premonition.
Yeah, so you can see the top roller there and their whole shooter plate. They do cover their inside, at least on the part that's able to move. And I think the bottom part is...
That tonight is getting strange, so I'm turning up the sound when you get in. 'Cause I can't watch you dig your own grave today. And I can't hear a word that you say, a word that you say. You got me going round.
All right, back up. Yeah, so you can see that there's that plate there, and they have it come down a little bit lower, but then largely there's just empty rails where the hood isn't. But there's enough of them that it's probably somewhat okay to do something like that. There may be some version that has polycarb there or something, but again, if we want to do foam, it gets a little trickier, but not impossible, right? You could just have different levels of compression, which may be okay. It's just a lot of things that we have to test to figure out if that's what we want it to do or not.
In circles in my head, the signals that we send, electric confidence. Push me, pull me down, pick me up, drag me around, parade me through the town, victory where we are.
Yeah, so this is a good view of the back. So you can see the gears moving the entire hood and everything. And they did have some adjustments in there, right? You kind of see it even, as it kind of moved right before they started firing here, maybe. Where am I at? Yeah, so they have that little bit of adjustment where the computer is locking on, but ideally ideally it's strong enough to not move at all. So those are things we want to figure out. One of the other things I've seen, at least from one other team, is instead of just relying on the servo to keep your position while you're shooting, they will they'll have a pneumatic brake that'll basically push in somewhere into the actual hood itself in relation to the rest of the stationary shooter frame, and kind of lock it into place. So you'd have like either a something that like locked into the gear teeth, or just even like a friction plate up against the hood. So you get rid of any of that. You're not worried about the motor holding the position anymore. Once the code has gone through and said, okay, we want to be at this angle, we believe we're at this angle, you deploy some sort of pneumatic, tiny little pneumatic that pushes pressure on it and stops the ball from being able to move it off that angle at all. So that's something we can think about when we're designing it into the system as well. Okay. Questions? Anything? James, anything I can help answer before we start going through this? I think one of the things we'll look at is how we're going to do requirements for it.
If you wanted to do foam, couldn't you like segment the foam in a way to where like part of it's on the adjustable part of the hood and the other part's on the part that doesn't move?
Segment it, it's almost certainly possible. You're talking about segmenting it, I guess, like vertical strips? Is that what you're saying? Okay. Yes. I think there's definitely a way to do that. The question becomes, how many vertical strips do you need before, like too many vertical strips gets complicated, right? That makes sense? Like if you have infinite, it becomes a problem in just like, how do you get really tiny vertical strips? And then if you have 2, it becomes this problem because you have like a left and a right half. So there's some number between 2 and infinite that may work. We just have to figure out how to get to that, like figure out how we design into that, and what makes sense to be a reasonable amount that gets you enough to where you're not losing consistency, right? Because if the gaps are too big, you end up not using the foam as much because you're just getting the ball pressed between the gaps, right? Does that make sense?
Yeah, that makes sense.
So I think that's a thing. But I don't know that matters. We also haven't done, part of the problem with doing all of this design work now where we don't just have the ability to test is kind of annoying because we don't know if we don't know what we don't know. And we have no good way to find out because we can't just build a prototype. We were pretty sure the foam did help us in season. I'm still confident that is true. Like the shots that we had without it were not nearly as consistent as the shots we had with it. But we also don't know if we need the foam if we have a top roller or not, right? Because with that, once you have the top roller, your exit isn't controlled by the compression at the foam anymore. It's controlled at the compression at the end with the double set of wheels. So it's very possible that we don't need to worry about foam. Okay, so from everything we just talked about, what are some of the requirements for shooter hood design that we need to be thinking about, right? Or what are some of the, not just requirements, but like design details, choices, trade-offs, whatever we want to call them, right? I guess first let's talk about it, like talk about trade-offs first, or even before that. What am I trying to do? Before that, what do we actually want to do, right? What's the goals of this whole thing? So we need to, what is the goal of building a adjustable hood?
Throwing the ball.
Sure, but we throw the ball without an adjustable hood, right?
We want to make more threes, right?
Yeah. So increase
Accuracy.
3%, right? Increase 3%. Increase. It's not necessarily increase accuracy, but yeah, it's increase 3%. To do that, you do need accuracy, right? Accuracy is going to be important. Accuracy, consistency.
Yeah, I was about to say that.
What were you about to say? Why did I stop it from correcting my typo? There we go. Thank you. Okay, so that's the goal. How does it do that though? So how are we increasing 3% with an adjustable hood? Like the super obvious answer.
Because it can adjust itself to correct where it's aiming.
Yeah, what variable is it adjusting though? Compared to a fixed hood that fires the ball one way, what are we adjusting with the
Angle.
The angle, right? The release angle.
Yeah.
So adjust release angle of the ball from the launcher. Okay. And so we have to be able to do that. We have to be able to actually adjust that angle accurately and consistently so that we can get our end product of the ball going where we want it to go, right? Okay. Are there any other, what are our other goals here? So while we need to maintain some ability to, what am I trying to describe? I should learn how to spell maintain. Some ability to, no, I wanted to, words not coming out right. like it's maintain the consistency of a fixed position shooter inside of inside of the adjustable one, right? So it's maintaining some of the rigidity and any other features that help with consistency. So possibly foam, foam compression, what did we do? There's something about keeping the ball straight as well, which is like the solid back, some sort of solid backing. Through our testing, the solid backing was better than like any sort of rails or anything. We did some testing right at the beginning, where we had either the foam back or just like the Lexan plate, any sort of like solid plate that compressed the ball against the 2-inch thing, right? You don't need no curving, ideally not rails, nothing like that. Okay. We also, what do we need? We need, we talked about it earlier in the presentation, but we don't want, because of what we're trying to do and because we want to be able to shoot at basically infinite positions and have pretty small adjustments to the hood, we don't want a pneumatic adjustable hood because that can only give us a limited number of positions, right? We need some sort of infinitely adjustable hood, which probably leaves us at either servo or motor powered. Okay. What was I thinking of? Okay, so what are some of those trade-offs? So one that we just listed is servo versus motor. What are other differences that we saw in the different, like, we just went through a bunch of different examples. What are things that people did differently on one than the other? Because part of what we have to do right now is kind of choose our initial path going forward, right? Here, let me make sure.
The hood staying still in relation to the rest of the hood, or I'm not sure what I'm trying to say.
The
different parts staying still.
Yeah, so whether what's the best way to describe that? Whether the motor moves in relation to the robot or whether the motor moves the hood in relation, right? What other ones were in the video? So we had teams that had a top roller or not a top roller, which is basically going to be related to hood because it's gonna be pretty important on how we design the hood, right? Versus no top roller, because we're not sure whether we need it or not. It's definitely one of the ones that designing it in is probably useful, but that also has to get integrated with the entire shooter design, not just the hood design. I mean, all of this does, but and then even with top roller has its own motor versus top roller powered by main shooter wheel. That because we also need okay, we also need what bearing setup, right? How is the How is the hood guided along its path? That sort of thing. Does it have a pneumatic brake?
An encoder.
Does it need external sensors? Or I guess, how do we know its position? That's probably better. Know its position. Coder built-in brushless encoder. Servo position control. Most of our answers probably. I think those are all the ones we saw here, right? We had the 971 had encoder, 118 this year had the brushless encoder, and then 148 and actually I don't know if I'm assuming they were doing it on position control. At least 125 is doing it on position control, most certainly with the servo. That's not even a word. All right. Anything else that we're missing here?
Maybe adjusting the angle from the front or the back.
Oh, that's a good one. Yep. Behind hood or near the pivot, something like that. This one's most likely behind the shooter, but there could be reasons to do the other way, right? We would just need to figure out what that is. But I'm pretty sure doing it behind the hood is the nicest way. We already kind of described why that's true. But basically, you're acting on it where the forces are trying to actually move it, which helps a lot in terms of keeping it stable. Okay, let's see. So looking through some of these, why some of these matter. So servo versus motor. Let's see. Motor, it takes a PDP slot. So that's potentially a problem, but that's based on the rest of the robot, which we don't actually necessarily know yet. More than likely, we have a PDP slot for it, right? Because this past year's robot had a motor dedicated to the forks, which we're pretty sure aren't going on any, like we don't have any sort of buddy climb system most likely in any future robot that we build for this game. So unless there's some other place where that motor would need to go for some other thing, that we probably have one that we could dedicate to the hood if we needed to.
The climber can also lose a motor.
Right, climber could go down to one if we wanted. There's multiple places we could probably steal or take motors from if we needed to. Namely, the indexer's at 2, which it might be able to be 1 depending on what the design is. It probably doesn't go up too much above 2. And then control panel, whether we have it or not, is a whole different thing, right? So worst case, we could just not have a control panel motor as well, which is a thing that could be done. Which you could potentially do. I still think there's probably a way to do control panel with servos if we needed to. Like it would be slow and you wouldn't want to do it as you wouldn't want to be the one doing it on your Champs Alliance, but if you just needed to have it for some reason, there's probably a version of it that can be done with servos. Or some sort of power takeoff to something else. Servo position control is done for you, which is nice. Doesn't take a PDP slot. What are other reasons to do motor over servo?
We haven't worked with servos very much.
That is true. More experience Motors. Ooh, that is true. Has there been a servo on any FRC robot for Spectrum? The answer is, was it no? Ooh. There's been multiple times where we've like designed something with a servo. I don't think any of them actually made it on a robot. The closest thing is like the 2013 little Frisbee paddles, which use the 393 motors, which are not servos. They're tiny and kind of look like servos, but they are not. So that is true. We have limited experience.
Do we own any currently?
Do we own any?
Yeah.
Yeah. We have there's a whole bag of Rev servos and like the programmer and everything. Like we've loaned them out at events and stuff all the time. Like it's more that we've had them for a long time. They're in Fight Electrical or AHP as it is also known. Probably the biggest one is the motors are going to have more power. And we can do more with that power. So it's likely that we could make it to where like the motors can adjust faster while still having enough torque. While still having enough torque to do what we need. Which one do we think is heavier or lighter?
Motor.
That's not an answer to a question that I wait, what?
What?
I asked which one is heavier or lighter, and you said motor, which I mean I guess
Oh.
is true. But
Motor is
also
heavier.
Complete information.
Motor is heavier.
That is you are correct. Saying either one of them is a valid statement. Which one is heavier or lighter? Motor. Correct. Way to play the odds there. Okay, so what are the other advantages of servo? So servo, you can do lighter. There's gonna be less gearing, right? We can basically you can pretty much do like one on each side. They had a connecting shaft, I think 125, I think 148 too, but I'm not actually sure. Have like a connecting shaft going through, which makes sense just in case something goes wrong. And you also want them mechanically linked so that one doesn't go faster than the other or something. But there's definitely less gearing involved. You don't have to have any sort of like belt and pulley reduction, gear reduction, or anything on the servo. It's probably going. There's gears already built into a servo. That's basically what a servo is. It's a pretty tiny motor with a gear set already in the little box and a potentiometer that's able to tell its position. That's all built into the little package of a servo. So it's already spinning at a rate where you can just like what 125 did. They adjusted the size of their gear to be able to set their speed, which makes it really simple. Where here, we would almost certainly need some type of gearbox. It could be even like the Ultraplanetary probably, where we can get a pretty big reduction off a Neo 550 pretty easily. But then we still have to figure out if we're putting potentially a motor controller on the hood or near it, right? Because you have to have the SparkMax somewhere near it, wherever the encoder cable is. You can't get too far away. 18 inches or so. You don't want too many extensions or anything like that. What was I gonna say? Servo is probably is for sure easier to program. So with a motor to do position control, you have to be able to set up. It's not too much more complicated, but there's definitely a lot more variables involved, right? We're gonna have to do some sort of control loop because we're normally just commanding it to go to some power level, but we have to tell it a position we want it to go to, which means we have to tell it, we have to tune it, we have to set up and build the smart motion for Rev, motion magic for CTRE, kind of variables in place so that when we actually tell it to go to a position, it actually does what we want. With a servo, you basically just send it a number between 0 and 254, or it's actually in our code now 0 and 1, or it's -1 and 1. I have to look at the servo library again. I'm not sure what happens when it's in position control mode. I'm pretty sure it's -1 and 1. And anywhere in that, it's going to turn to that value and get you a pretty consistent position control, because that's basically all it's designed to do, is do that position control. There are various servos that have different gearing and speeds already. Various legal servos with different speed and torque. So that's why 125 used the rev servos, which are fine and work, and they're pretty good. 148 used, I believe, slightly more expensive servos. They're like, you can get them on Amazon, I'm pretty sure. I think I'd have to go look at exactly which ones they used. There's a variety of them that have different, you tell them like the same position to go to, but then they'll drive there either faster or with more torque. So that may be enough for what we need. Okay, so what else do we need to discuss on hood design? Any questions? Things that don't make sense?
Yeah.
Okay. So I think part of what we have to figure out is how do we want to move forward? So there are things that we also don't, one of the biggest ones we have not currently discussed is how much angle adjustment do we need? Right, that's a lot of what we're doing, right? Do we only need to be able to adjust between 5 degrees? Do we need to adjust between 15 degrees, 20 degrees? How much do we actually need to be able to vary our shot for the amount of positioning that we actually want, right? That probably sets up a bunch of what we need to do, because why does that change things? Because a servo gets a lot easier if we're going over a much shorter distance. Then you're just not traveling as much, right? And you're not worried about how fast it's going to take you to go from full down to full up. So part of that is going to be where on the field are we trying to be able to shoot from, right? So now this is back to less a mechanical decision and more a strategic one. The biggest one is going to be, do we have the ability to shoot from somewhere near the target zone right up against the goal style shot? We have not had that discussion since probably, the first couple days of build season. Any opinions on that?
So right up against like the wall.
Yeah, so not necessarily right up against the wall, but anywhere where your bumpers are basically in the target zone.
Okay, gotcha.
What was I figuring out? So like there are people who used it very effectively. So part of the kind of weird thing about knowing that we have this game again is knowing that other people already played it, right? So like Orbit, they were a small robot, but they had a very effective, this seems like a 14-second video. I don't know what's happening there. That is incorrect. Let's not do that. That seems like a more reasonable video length.
הצד האדום. אורביט לא עושים אוטונומי.
Okay, so Orbit is here in blue.
Mhm.
I'm pretty sure by then they were doing most of their cycles from. Or are they just playing defense in this match? What's happening? Okay. Different match.
2 for 2.
That match did not work. Let's go back a bit. All right. Oh, man. All right, 1690 is in red. All right, here they come. All right, so they go fire, and they have this shot pretty up close, but they were able to sink they were shooting a pretty high percentage of threes from this kind of weird shallow release angle, or I guess not necessarily shallow, like more vertical, very steep release angle.
Yeah, they get very close.
Right, and they were shooting multiple threes in this thing. Like, there's some matches where they were hitting very high percentages of threes. And that's actually harder to do from a shorter robot than it is from a taller robot because their angle has to be even worse because they're so short. Which they're not that short because they flip up their whole shooter, so they get pretty tall. But it's still quite a bit shorter than what we would be shooting at as a tall robot. Well, that's not good. Their shooter jammed in some way.
Yeah, it's stuck.
Okay. So there's some decision as to whether that shot is important or not, because that changes what we are that limits somewhat of what we're able to do, right? Can you actually, does making that shot make sense? Does it not make sense? Is an argument I think we have to have at some point before we get too far down the shooter hood design, because that's going to add at least probably double the range of motion to what we need for most of the other back shots. Because there's almost certainly the zone where we don't ever care to shoot from, right? It's that like kind of initiation line forward towards the target zone, that like gap area. There's no real reason to ever shoot there, right? We can be behind initiation line and be fine. There's value in being able to go all the way to the target zone since that's protected, and potentially, if you can do it, a more consistent shot since the ball has to fly less. Right, there's just less time for it to. There's less time for it to deviate off of its path if you're shooting it in the air for less time, right? So a small angle, a small problem in angle or velocity get less amplified the less it has to be in the air. So that's actually an argument for actually shooting in that weird no man's land range anyway. I mean, ideally you just move all the way forward though, if you can do it. But it also adds complexity, and that I said, again, it makes the shooter hood need to move over a greater range.
How much complexity are you actually adding?
So most of what I think happens, and I think it will happen a lot when we get into the design, is how that overlap happens, right? If you only have to move a little bit, that overlap only has to be a little bit, where if you have to move a lot, you have to figure out how to overlap way more, right? Does that make sense?
Yes.
So I think you can do, I think the movement is probably going to be the same. And I guess some of that is also just the amount of time it takes to move from like full forward to full back, but you also shouldn't ever have to move from full forward to full back. Right? Like if we do code properly, there should be some way to prime the robot to be going towards one of those two positions before we get into our shooter spot, right? if we know we're taking a back shot, operator can hit a button that moves the hood towards its forwarder position, because we know we're taking a deep shot, and then once we're in position, it can move to the actual correct one. And if we know we're going to the front, the operator can hit a button that moves it towards its steepest shot, and then it can move to its actual position once we're there. So I think you can get rid of that time variable and how long it takes to move from one to the other, just by having operator do some of that. So I don't think that's too much of a detriment. So yeah, I think it's really just how does that overlap work, and the space that we build into all of that movement. But we also have a lot of time to design it if we start now, because right, we're not competing until March,
Yeah.
at the earliest. So,
Yeah.
so yeah, so adding that little potentially small amount of complexity, and or it's not even really complexity as much as just like, I guess, space, right? Most of the same thing is going to happen. It's going to happen over a longer distance. So I still think we need to figure out some idea of some reasonable range. Like we probably need to look at our shooter calculators again, and figure out kind of what release angles we want to be looking at. What other questions do we need to talk about and kind of just start figuring out what we need to decide? Like we don't need to decide it today, but we need to start figuring out what we do need to decide.
Like for the shooter or just like in general?
I was mostly talking about for the shooter.
Okay.
And just like the shooter hood, even more specifically, right? The rest of it we can also change. There's a word missing. Your computer makes the weirdest noise.
I know. It's been going for like 15 minutes. Just gonna keep going.
Okay, does anyone have, I'm trying to think like what we need to, how do we want to base what we're doing? So I like parts of what 125 did in that it is simple, right? There's no real part of this that isn't relatively easy to build. I think there's some version that has these rails possibly thicker, because that kind of gets to what you were talking about, James, right? If these rails were thicker and had foam on them, you kind of get that vertical segmentation. Right? Okay. What was I going to say? So part of how this setup has to work too is there has to be some sort of bearing guides that slip along here, right? So there's a there has to be a connected shaft going all the way through. Actually, I don't know if there is. No, there has to be. Something has to hold these rails at the top, right? Yes, probably. I don't actually know that that's true. Yeah, there's almost certainly some sort of bar holding these rails at the top that these are sliding through, right? I can't imagine there's not. Wait, no, but they're not with the way that this edge though is, right? Like there's no point for that to. Okay, I don't know how they actually did that. I might have to ask 125 how they did this. because there's the way they do the sides, right? There's no slot here for a tube to be sliding through. So how these are connected at the top gets interesting. Like there's no point for them to be like attached to a side panel or anything. The little like internal stationary slots, they may just be attached to each other. I'm not even sure if they're attached to each other anywhere. That's definitely something to think about, is how that rails kind of work, or how we would like to do something similar. Okay, so what do we need to do? So yeah, so I think our kind of like progress moving forward is we can take the shooter that we have and assume it's going to be somewhat similar to that. We'll have a 6-inch shooter wheel, and then some way to adjust. We need to figure out how to actually build out the guides and stuff to adjust mechanically adjust it this way. I guess right now we can also discuss the trade-offs between doing I feel like the belted setup to the top roller is easier than doing a motor specifically for it. Anyone have, what was I gonna say? Anyone have ideas why you would want the top roller to have its own motor versus the top roller being belted to the main shooter?
Stop him from spinning, to stop the ball from spinning. Because with a belt, the wheel would be going, one wheel would be going one way, the other one would be going the opposite direction. So there'd be a spin on the ball. But if it's two different motors,
No, you always reverse the belt. So yeah, if you look at 125s, sorry, I didn't explain that. So if you look at 125s, that's a double-sided belt, and it goes up along these pulleys. So they reverse this shooter in the mechanical linkage.
Oh, okay.
Does that make sense? So you could do that as well with like a belt and then a gear set, if you want to do it even easier than having to do like their double-sided belt thing. But yeah, that is a good point. You can't just belt directly. That would be bad. If belt directly, it does the exact opposite of what we want it to do. So yes, you do need to, but what this does do is the belted setup sets your speed difference, right? Like you have only one difference between the main shooter and the top roller. Whatever you gear it to, they're going to spin in that proportion at all times, right? Can't adjust the speed difference. Where if you have your own motor, you can, right? We could completely stop that top roller and have the bottom roller spinning alone. We could have the top roller spinning faster for some reason if we wanted to. That would be kind of silly, right? You'd get weird top spin and stuff that you probably don't want. But that adds complexity, right? Because you have to have a motor on the hood now, or you don't necessarily have to have a motor on the hood, but you have to have, I guess because you could do it with its own motor, but then still have it somehow belted down to a stationary motor. There's probably some version that does that, but it's still, no matter what, it adds some, it adds control complexity. And potentially some mechanical complexity. This one for sure adds mechanical complexity. That's somewhat in relation to whether you have it at all or not, right? No top roller has a lot more backspin. More linear velocity. Something like that. Oh. What am I trying to figure out? So yeah, so is there so the other problem with own motor is it takes another PDP slot, right? Which, depending on if you use servos or not up here, we may or not have that PDP slot. Also, it also depends on the whole rest of the robot design that we still don't have a really good grasp of yet either. If they're mechanically linked, they're going to be spinning at the same proportion at all times, even if the control loops aren't like adjusting at the same speed. Because you can imagine if they're on two separate motors and we fire and they're going at the speeds we tell them to go to. As we push a ball through, both motors are going to slow down, right? And then have to reaccelerate. When that next ball comes through, we don't actually know where they're going to be together, right? It's very possible we could get them tuned to where by the time the next ball comes through, they are at their set point again. But it's also possible that when they go through, the top roller doesn't quite, or the top roller gets back up to speed, but the bottom one doesn't. And now you have a different shot where if you do it mechanically linked, they are at least proportional to each other at all times, right? So if they both slow down and they don't quite get back up to speed, they're both doing the same thing. So you at least get the same spin coming out, even if they're not at the right velocity, which I don't know if we want or not, but that at least is definitely a difference.
Is that a reason to have a flywheel on it?
So that's also depends on whether some of that is just how much motor power you can put into it, right? Like if we can just get it up to speed every time the ball's through anyway, it just kind of works, right? And that's kind of that's what we did this year was we had a heavy enough wheel. The Coulsons were heavy enough that the Falcons were just able to get back up to speed almost every as each ball was coming through pretty reliably, which I think we can do again and not have to worry about as much mass on a flywheel if we don't have to. But that's something we could look at. Because the flywheel does hurt your like initial shot, but that may not be a problem if in like Aton, if we're driving anyway, it doesn't really matter. Because the most likely scenario is you're driving to get balls before your first shots anyway. There's ways where you don't have to, but you could. It kind of depends on what the Aton routine is or not. Okay. What did we not talk about? Motor moves or hood rack moves, right? In general, it's probably easier if the hood rack moves. Right? From all the examples we've seen, it makes sense that that's the easier one because once you're moving the motor, you have to deal with the wiring, moving along and things like that. I'm trying to think where there would be. Anyone have any other places where there's reason for the motor to move instead of the rack gear to move?
If you have the motor for the roller up there also, then you already have to do wiring.
Yeah, you do, but even then, I'm just trying to figure out what was the big reason why.
118 did it.
Yeah, so I'm trying to think. So you can get, let's see, your bearing setup stays that way, but that could go. Well, I guess everything can be in their whole setup could be could take up that space where the gear normally would. Right, because when they inverted it, they're able to package everything into the same space as like the gear kind of would, and then they push the gear out to the outside, which is a convenient way to do that. Is there a way to do that while it's still stationary? Oh, that gets weird. Yeah, it's hard to just kind of describe the differences here. Because it's really just like a packaging for each kit is different, but it's not necessarily, one's not necessarily better than the other. The wire management isn't too bad on it, something like that, because you're not moving all that much distance, right? So you can just, you can put it all in like a wire loom or whatever, like a cable loom, zip tie it, and it's not going to get caught on anything or do anything too bad. If you need bigger gears, it definitely makes sense to have the rack move probably. So like the way 125 setup works, if you did it the other way, it gets kind of awkward, because your internal rack has to be so much, or your internal like mounting and plates have to be so much bigger to hold the external gears and stuff, right? If we were to like invert this to where the rack was stationary and the motors moved, you have this weird, like these internal plates have to get really big to hold these servos and everything, which is not necessarily what you want. Okay. Other things we should talk about? I think part of it
Alan,
is.
are you gonna be post?
Sorry, what's up? I missed what you just said, Grisha.
Are you gonna be posting this in the Slack?
I just did.
I said, are you gonna be posting this in a Slack? Like link?
I just did.
Okay.
It's a mechanical. Yeah, so this document's in Slack. The hood design is also in Slack. Yeah, so and it's also just in our drive. If I'm ever working on a doc and you can't find it, it's always in drive. Just go search the title and it'll always come up. Or ask me and I can throw it in the chat or Slack or whatever too. Yeah, so so I guess James, if you want to be working on a hood right now, what are the things that you would want to be working on, or are those things we can still decide or talk about to kind of get you moving in the right direction before we end for the day? Or if other people want to work on a hood, that's also totally fine. Like I said, we have lots of time to be doing stuff. So.
I mean, you've pretty much covered everything that I was thinking about, so I'm pretty sure I'm good.
Okay. Yeah, I think just like part of it is getting. I was talking to Felipe the same thing. Kind of getting out some block details. Like we don't need to like. You shouldn't basically. Don't like try to worry about getting the gear teeth right on the rack and all those fine details. Right. You want to be thinking about, okay, how do I get the overall structure and kind of like going through and kind of choosing some of these things first, right? And kind of laying out even quick kind of block Crayola cat-ish things, and then coming back and presenting it and talking to me about it, so we can pick out problems there. Because once you've like kind of started like building out gear racks, it's way harder to change everything, right? So we want relatively simple, quick CAD things. Be like, okay, this is where I think there's going to be a bearing. Probably shouldn't even be a bearing yet. It should just be like a weird cylinder you drew real fast, right? And then we can go in and figure out where all the hardware is and everything as we go. But as high level as we can do the first parts of it, where even if they're, feel free to like, if there's just a servo and you want to import it, it's fine, but don't worry too much about getting the exact servo mounting right. If the servo is just floating in air, that's fine for a while, or the motor or whatever else we decide to figure out how to do. Servo with brake seems the easiest to me. Because one of the disadvantages of the servo, it doesn't have a lot of power, but you don't care as much about power if you have a pneumatic brake that kind of locks the whole thing in place when we go to actually fire. The only disadvantage about that is that you aren't able to, if someone's pushing you forward or backwards, or if you're like driving while trying to shoot, you aren't able to hit threes consistently, but at that point, I don't think we're trying to do that. I don't think we're that worried about getting, we're not worried that much about getting shoved off our spot. If we're shooting under defense, we have other issues happening, and we're like, our 3% under defense isn't as crazy important. As part of our decision-making is that we assume going forward at the highest levels of play, most teams will be playing something close to triple offense, where you may have defenders, but most of your cycles are shot undefended. If the game turns out something different, we'll figure it out from there. But I don't think you're going to have that many. We shouldn't have a defender on us the whole time. One, there's another robot. There's multiple other robots. We can probably find a place to get relatively open shots if we need to.
I think it happens more often in quals.
Right, but you don't care about your 3-point percentage there.
Okay.
Right, like you're in the vast majority of qual matches when you have a defender on you, you're just going to be able to out your alliance's ball rate matters more than your 3% rate in qualifications. Does that make sense?
Yes.
Because you almost certainly, most qual matches you can put up more balls than your opponent. You still want to be able to take threes, absolutely, but your 3% doesn't matter as much compared to an elims, where if you're both playing triple offense, you have two very good robots on both sides. When your ball rates are going to be very, very similar, then your 3-point percentage matters that much more. Does that make sense?
Yes, but what happens when you go up against a good team in quals?
Happens when you go up against a good team in quals.
Like a team that can match your ball rate. Do you just count it as a loss?
No, not necessarily. But part of your goal is to just work on getting your ball rate faster, right? So that means shooting from. It's unlikely that they're also able just to magically make all their threes too, right? Because you probably have a defender on them, and once the game is played 2-on-2 with a defender, most of it is just who can put balls in the most, which changes your driving and shooting strategy, right? Like you're able to just go and get balls and figure out protected spots to shoot and just make sure you're making all of your balls. Like your actual make percentage matters more, even if they're just twos. Same with your climbs. Like there are going to be matches where it gets closer, but some of that is you'll still have some shots where there's threes. Yours not going to be nearly as clean as when we think we're playing triple O, where every ball matters more. because some of that's going to be who's playing the defense, and just can those two teams match up, right? Like there's very few qual matches where you actually get four playoff caliber robots in the qual match, right, and split the same way. Like sometimes it works, but it's pretty rare that it's like, oh, this could be a playoff match. That's not clearly one-sided. And I don't think we also want to like design everything to go about doing that, because if you're doing that at that point, then you need to be like a master class everything robot, which I don't think you need to do to be able to win the world championship. Because this whole like, I can shoot all of my threes while driving. It's like, okay, can you? And like, if you can, that's fine. But are you that much better than me who can shoot all of our threes while sitting still if we're still hitting the same number of threes in a match? In a match where it's played triple offense, where I think where it makes sense that it goes, because there's just enough balls on the field. There will be enough robots, assuming we have anything close to a regular season. There'll be enough robots who can shoot balls well enough on your division that ideally you're playing some form of triple offense. Because it's just that much harder to take points away from another alliance who has enough protected zones and good enough robots to be able to make shots. But yeah, going through and having that strategy discussion, because this is only just random things that I've thought about and talked about with some of you in different conversations, but we can definitely have a group one at some point too, because the strategy of the game somewhat changes. And again, none of this is even set in stone, is that the game rules haven't come out. We don't know what they're updating. Probably not much, but they could be updating some things. And then also just how much time we actually have to build and do things is determined on a whole lot of things that happen in the next multiple months going forward. Okay. Cool. I'm going to stop the recording.